So we have got our first term here using binomial expression. Let us get the second term as well. So second term, again if we see this, r2 square is equal to r square 1 plus 2a cos theta upon r. Please excuse my writing because I am trying to write with the mouse, so it is quite difficult, as you know, to write with the mouse. I don't have any equipment to write on the screen. So this is this. Now if we take a whole thing in denominator, r2 square is equal to 1 by r square, and this goes into denominator 1 plus 2a cos theta upon r. If we take under root, so this will simply become 1 by r2 equal to 1 by r, and this whole thing will become under root of this. So this is 1 plus 2a cos theta upon r to the power half. When we take this thing to upper side, this will become minus half. So this is this 1 by r2 is equal to 1 by r, and this 1 plus 2a cos theta upon r to the power minus half. So this is exactly the term that you get here. This is exactly the term that you got here. This is this. Now applying again the binomial theorem, because this term is much smaller than 1. So when we apply, so we take this power inside and apply power on this term. So this is simply 1 by r 1. Now this time 2 and 2 cancels out, but plus becomes minus. So a upon r cos theta. So here we got this term and this term, both the terms we have got. Now after getting these terms, so now if you go to this equation, so we know what is 1, we know this constant, we know charge because we have placed the charge. What we were trying to determine is 1 upon r1, 1 upon r2. So if we know 1 upon r1, 1 upon r2, so then we can solve this equation. How? V is equal to, this q is common because both the charges should be equal in magnitude. Only one is positive, another one is negative. Q upon 4 pi epsilon naught, and in the bracket 1 upon r1 minus 1 upon r2. This was what we were trying to get. Now we have got what is r1, 1 upon r1 and 1 upon r2. Let put the values here. So this is 1 upon r1 and 1 upon r2 we have got. So this is simply, the equation was simply q upon 4 pi epsilon naught, then 1 upon r1 minus 1 upon r2. Okay, so this is q upon 4 pi epsilon. Now 1 upon r1 and 1 upon r2, let us put. So this is value of 1 upon r and plus 1 plus this is, let us put this value. So v is equal to q upon 4 pi epsilon naught, and the value of this 1 upon r1 is 1 upon r. 1 upon r, let us take this 1 upon r as well common. So this is common. So this is 1 plus a upon r cos theta. So this is 1 upon r1 minus 1 upon r2. So minus this we have already taken common, 1 upon r minus 1 minus minus, this becomes plus a by r cos theta. So this 1 goes out and this v is equal to simply a upon r and a upon r, 2a upon r. So 2a q 4 pi epsilon naught was already there, one r was there, another r is from here, r square and cos theta. And we know that this 2aq is p. We know dipole moment p is equal to 2a into q. So this is here, so applying p instead of this, so this will become p cos theta upon 4 pi epsilon naught r square. Now what is p cos theta? Let us see what is p cos theta. Let us again go to this diagram here, p cos theta. So theta, for this p cos theta, so this is p dot r, because r, here r we are taking the unit vector r, here we are not taking that r vector, this is unit vector r. So this will become simply p cos theta. So p cos theta is p dot unit vector r. So now p cos, instead of p cos theta we have simply applied p dot unit vector r. So this is the potential at much larger distances than the separation of two charges. Now as I said, this r is the unit vector along the direction of OP. What was O? Midpoint of this, and this point was P. So this is the unit vector along this direction. Now this equation 2.15, this equation as indicated approximately true for distances large. So this is the condition. This is true only when the distance is compared larger compared to the size of the dipole. Size of the dipole is 2a. 2a is the size of dipole. This is only true when r is greater than 2a or r is greater than a. So this is true only then. Now if we take for a point, so last time when measuring the electric field we considered that if this is the dipole, so we considered two condition, when the point on the axis of dipole and point was on the equatorial plane. So when we were calculating the electric field, we considered two cases. The point is on the axis of this dipole, or the point, second case, this was first case, this was second case, that the point is on the equatorial plane of this dipole. So equatorial plane was the plane which goes through the midpoint of this dipole. So these were two cases. So we solved this. So let us see for case 1 what happens. So for case 1, the angle between, this is r, direction of r, and this is also the direction of dipole. So let us say this is minus q and this is positive q, and the direction of dipole and direction of this point P both are parallel. Hence P dot r will simply remains P, because cos theta is cos 0. So that in that case, this is simply V is equal to positive 1 upon 4 pi epsilon naught P upon r square. There would be another possibility that instead of positive charge on the left side, positive charge could be on the right side. So in that case the direction of the dipole would be reversed. The direction of the dipole P is reversed. So P is in this direction. So now the angle between this r, unit vector r, and this P is 180 degree. So in that case, cos 180 is minus 1. There would be a minus. So this same thing with minus. So minus 1 upon 4 pi epsilon naught P upon r square. So if we see the potential due to a point on the axis of dipole due to this dipole is always plus minus 1 upon 4 pi epsilon naught P upon r square. So this is always true for a point on the axis of the dipole. Now if this at this point too, so for any point on this axis, if we see, so this is r, unit vector r, this is P. So here we can see the angle is always 90 degree. Angle is theta is always 90 degree for any point on the equatorial plane. So cos 90 is 0. So now cos 90, since cos 90 is 0, so always a point in this plane will have a potential 0. Any point on this plane will always have a potential V is equal to 0 because angle is 90 degree.